My name is Devin Colon. I'm with group something. This is my 6-minute talk. I'll be talking about the refrigeration cycle. Sorry, Philip, but I'm excited for this one. Some quick history. I'm going to go back to that if I have time. But layman's explanation. So cold temperature is produced when you vaporize a liquid. So to vaporize a liquid, you need to input energy, and that energy is going to be pulled from the surroundings, cooling the surroundings. It works both ways, but that's basically the operation of a refrigerator. So the whole reason I'm doing this presentation is because so often we're taught all these concepts, numbers on paper, how to do calculations, and it's like good and dandy. But when you get out into the real world and you look at these systems and you talk to somebody that's been dealing with them for 30 years, they talk to a student that came from a college, and we end up looking naive, and it's really frustrating. You know, they look down like, oh, you're just a dumb college kid, you don't know what you're talking about, so we're gonna see what you do about that this time. So going based off what we know, so you have your evaporator. We'll start with the compressor actually. You have your compressor, it starts at just barely a vapor. So it works across a saturated mixture as you go across, but right when it reaches a vapor, for efficiency reasons, that's when you enter compressor. You don't want any liquid in the compressor because it breaks compressors, we know this. It moves it up to superheat. So you have this gas that's superheated and wants to cool off. So as it goes through the condenser, it works its way through saturated mixture, condensing, and it wants to cool off, so it's rejecting heat to its surrounding. That's your heat pump. And you work all the way from saturated mixture to almost a full liquid, or a full liquid when it goes into the expansion valve, but it's high pressure. The expansion valve lowers the pressure, and when it comes out of your expansion valve, that's the coldest your liquid's ever gonna get. Very cold, and it wants to pull heat from wherever it is around it as a saturated mixture. So you go through your evaporator, and it's pulling heat in, AKA cooling your surroundings as it's moving back towards superheated, and then the whole loop repeats. We know this, but just think about those states when we move forward. Here's some of your basic equations. Give you all a minute to look at it. We've seen it before. Enjoy. So thermostatic expansion valve. We're going to quickly recap this real quick. So one of the problems you can run into with your evaporator, if it gets too cold, it'll actually freeze up the fins and you'll lose airflow and you'll lose like what you're trying to do with your system. So what it does is you have your sensing bulb filled with your fluid. When it gets too cold, the pressure is reduced and it allows your valve to seat, reducing refrigerant, allowing your evaporator to become warmer so you can avoid that freeze over and loss of flow. And then let's say that your system heated up, like you open the door to your refrigerator and it's getting too hot in there, that increases the pressure here on your output, opening the valve, letting more refrigeration. This is good for efficiency because you're adjusting your flow of refrigerant given the condition, and that's gonna turn into adjusting you running your compressor using just the energy you need to do what you want to do. So here's a representation of a refrigerator. We talked about this. But as you can see right here, it uses capillary tubes instead of a thermal expansion valve. Capillary tubes are fixed. They use the volume and the length of them to adjust flow and pressure. They're cheaper. They don't have any moving parts. They're less complex. And that's why you're going to see them on low to mid-grade refrigerators. The thermostatic expansion valve is more complex, it has more moving parts, so therefore it's more expensive, and you'll see it on high-end refrigerators or commercial refrigeration systems. Going over the topics again, you know, your compressor makes it superheated. It's this gas, it's really reactive, it wants to calm down, and to do that, it's going to work its way back towards, through a saturated mixture into almost a liquid. And doing that, ooh, I think I did that backwards. Kinetic energy, yes. So yeah, it rejects heat to the system, that's pretty cool. And then it works through the capillary tubes, reduces pressure, and you got your evaporator, bringing it back to a superheated mixture. And it's doing that by pulling the energy in, whatnot. But when you're looking at your refrigerator, this is what you're looking at. You have your compressor and your condenser at the bottom. You have your expansion valve somewhere. Sometimes it's not visible. You might have to pull a panel off. Evaporator coils too. I actually pulled my refrigerator away from the wall. I couldn't see them, so I'm assuming it's behind a panel, but you can't see it from the inside either. So I don't know, access that some kind of way if you want to work on it. Fun fact, because your condenser and your compressor are on the floor, they're prone to dust, dirt in your house. And that dust will collect on the condenser, like decreasing flow and reducing efficiency. So every now and then you should inspect your refrigerator and remove dust or particles if you can to make it a better system. Also, that compressor gets warm, and we live in Louisiana where bugs like to live. So, you know, if you're putting out roach traps in your kitchen or whatever, that's a great spot to put them because roaches love that heat. Air conditioning in your house. So, most of y'all probably know this, some of y'all don't. You have vents in your house, and when you pull them out, those filters that get really dirty, that's gonna be right here. You do that to keep your evaporator coils as clean as possible. Same thing with the refrigerator, I just said, you wanna keep particles off of that so you can maximize flow. And some houses that are built conveniently, but you know, more recent, when you pull that filter off, you can visually look at your evaporator and see if it's dirty and if it needs to be cleaned. Same thing with your outside unit. Your outside unit contains your compressor and your condensing coil. Sometimes this will get collected with like leaves and stuff, debris, decreasing flow, so you want to keep it clear. And again, visually inspect it, make sure all that stuff doesn't accumulate on it. Keep your system working nice. As far as the car goes, same system, right? Your condenser, where you're rejecting heat, is gonna be, it looks exactly like your radiator. Usually they're stacked behind each other or in front of each other, however that works. Your compressor is gonna be mounted to your serpentine belt. A lot of times if you're having problems with your serpentine belt, one of the issues you could be having is that the clutch messed up in your compressor and it's causing it to slip, and you get damage there. Your evaporator is typically behind your glove box. So if you remove your glove box and remove the filter, you can visually inspect your evaporator for particles there. Your receiver dryer is typically going to be right behind your engine and directly in front of your firewall. So when you open your hood and look all the way to the back, like right underneath your windshield wipers, you'll be able to see that. Where's our time at?
You're at 7 minutes.
Yep, that's it. Good job.